Lucas. So, okay, if I got x squared plus 12x minus 64 equals 0 now on the left-hand side. I need to factor this. This is a quadratic. I can factor this. Diamond problem. Oh. Negative 64 and 12. Can you think of two numbers out there in the world that multiply to negative 64 and add to 12? I can. 4 and what? 4 and 8 is not 64. But if you double 8, okay, now, let's make the signs work out. They need to add to 12, but multiply. So which one has to be the negative? Yeah. So this is x minus 4, x plus 16. So therefore, by the zero product property, your answers are either 4 or negative 16 by the zero product property. Remember that, folks? Because now that you see it comes back? Okay. We're going to use that in the homework tonight. That's why I'm showing it to you, okay? You love that unit. Stop it. Okay. All right. Okay, regardless. Now you've seen it, let's talk about the two theorems. On your toolkits, please draw these two theorems, okay? So move over to your toolkit and put these two on there, okay? Yeah, we're going to do both of those today. It's off from the upgrade, that's right, yeah. All right, so question to you. These lines that I have here, E, B, are those secant lines or tangent lines? And how do you know? Hey, very good. Why, they're secant lines, right? Both of these are secant lines. Okay, so this one's a secant line, and then that one's a secant line. So, because the other theorem is going to deal with a tangent line, so I want to be able to differentiate the two. All right, I'm going to highlight EA, and then I'm going to highlight EC. Those are called segments, right? Little segments of that secant line. So here's what Theorem 10.16 says. We can take EA and multiply it by the entire length of that segment, EB. Okay, so just the front part, like the outside part, multiplied by the whole thing, has to be equal to the other outside part, which is EC, times the whole entire thing, which of course is ED. Okay, so that's Theorem 10.16. It says the outside segments of your secant line multiplied by the entire secant line has to be equal to the other outside segment tangent line. So draw yourself a circle. All right, on that circle, give yourself a tangent. So I'll call it tangent A. You can call it whatever you want. So I've got a tangent line here. And then give yourself another secant line that goes through our circle. So it'll look something like... We're good? Yeah. Okay, let's finish layering up that circle, all right? All right, so I got A. Let's put E on the outside, everybody. Let's put an E over here, and let's put a C here. And then let's put a D over here. That doesn't look like a C, huh? It's terrible looking. All right, I'm going to highlight the outside part of both my tangent line and my secant line. So here's the highlighted part. And then here's my outside highlighted part. Now, let's think back to the other theorem we just did. Notice that it was the outside part times the whole thing, right? EA times EB. So could you take a guess then as to what you think the right-hand side of this equation is going to be for this theorem? EC times what? No, the whole thing, right? The whole thing, ED, right? Okay, but what's the other part? AE times what? There's no more to it. So we have to, what should we times it by? Yes, you picked it up. Nice. It's just EA squared. Since there's no other piece to multiply by, we just multiply it by itself. So we got EA squared equals EC times ED, and I'll highlight those for you so you know exactly which piece is which. All right. So, back to your notes over here. Give yourself a circle. And give yourself two secant lines. And that should be a clue as to which theorem you think we're going to use here. You got it, boss. Yeah, you got it. Okay, so we'll call this point F. We'll call this point E. And we'll call this outside point D. Call this G. Call this H. And I'm going to give you some information about this circle and about these lines, okay? The first piece of information I'm going to give you is that FE segment is 10 units. Second piece is going to tell you that ED is 11 units. GD is 12 units. And then, of course, you got to throw a variable in there to make it interesting. Okay, so my question to Marilyn, you came up first. Marilyn, which theorem are we going to use? Are we going to use 1016 or 1017, and how do you know, Marilyn? 1016, why? Because what? Because the figure matches? Okay, what type of lines are these? Are these secants or tangents? I'll give you two choices. They're secant lines. You're absolutely right. Okay, now if you're going to get this wrong, you're going to get it wrong because you don't set it up right. So let's set it up correctly. According to the theorem, we take the outside part, which is 11, and we multiply that by which piece, everybody? The whole thing, which is 21. 11 plus 10, which is 21. Good. That part has to equal the outside piece, which is how much? 12. Good. Multiplied by, now, don't mess this up. What's the whole thing? Not 12x. 12 plus x. That's where you make a mistake, right? So it's 12 plus x. Okay, we all have calculators in front of us. Let's see here. 11 times 21. 11 times 21. What did you guys get? 231. I'll verify that. Nice job. Okay, so 231 has to be, distributive property time, right? Don't forget your distributive property. 12 times 12? 144. 12 times x. Plus 12x. Don't forget the distributive property. Distributive property. Okay? Don't forget that. Look at your algebra books. Okay, finishing this up. Solving, I'm going to subtract 144 from both sides. And what's 231 minus 144? You fact checkers. 87? I believe you. Equals 12x. And to finish this off, Jared, what do I do next?
So you divide 12 each side.
Say again?
Divide 12
Yep.
each side.
Uh-huh.
You get 7.25.
7.25. Can someone verify that? Equals x. Bless